We'll proceed in vector algebra and calculus. Vector algebra and calculus. The topic we are making huge effort in demonstrating vector algebra and calculus because we believe that that is the future in mathematics. Either it is Bayes theorem, either or it is something the neural network. Bayes theorem, it means that it is a NLP, natural language processing, where Bayes theorem is used, or it is a kind of neural network. It is KNN, K nearest neighbor, or something like that, and then it is many other things, dimension reduction ability, and other things. Everywhere calculus is used, everywhere algebra is used, everywhere mathematics is used, but they are not complete without the direction. If direction is not there, then I'm not saying that without direction it is something like something is completely incomplete, but they are certainly incomplete. Okay, like if I am kind of okay, if I am getting example I give like I am getting 10 rupees in my hand from someone. 10 rupees, I got 10 rupees. You got 10 rupees. All right. Very nice. Miss, no one would ask anything. You got 10 rupees. Yes, I got 10 rupees. Okay, very nice. I got 10 rupees. After 1 hour, I got 20 rupees. Okay, after 1 hour, I got 30 rupees. Then anyone would ask, who gave you? Who is the person who gave you 20 rupees and 20 rupees and 30 rupees or $10, $20 or $30? Who gave you? This is the direction. From which direction money is coming? Okay, if you talk that money came, then no one would ask. Okay, money came. But if you repeat things, money came this much, money came this much, money came this much, money came this much, then people will ask where from money is coming? Where? From which direction? So vector comes into the picture when mathematics start taking advancement. If mathematics start taking advancement, then direction comes into the picture. There, vector hits. Anyway, the biggest thing what we see in the kind of vector is energy calculation. Energy calculation. If I have a magnet, if I have a magnet, and if I have an iron, then iron is attracted by the magnet. Magnet, iron is getting attracted towards the magnet. Okay, people think that this is the end of the story. Okay, so magnet, iron is getting attracted toward the magnet. Then, okay, then I take another, I take 100 iron. Okay, one iron, if I leave, it go and stick on the magnet. Then I dissociate it. Another magnet. If 100 iron, if I leave like this, they move toward the magnet. Okay, after 100 iron, they are sticking to the magnet, and then I calculate the magnetic field which was there prior to the first iron got stick to the magnet. Then what is the quality of the magnetic field? Magnetic field is decreasing, means magnetic force is decreasing because magnet is working. If magnet is attracting something, magnet is working. Work means energy. Work, the symbol, the notation of the work is joule, and energy symbol notation is also joule only. So if that is the case, then magnet is working. If magnet is working, magnet is losing energy in each work. And after 100 times we did, certainly magnet has lost the energy and magnetic field is decreasing. If you continue, then it won't be magnet at all. This proves that there is energy that comes out of the magnet. Okay, now we are in calculation of how much energy magnet is losing. How much energy magnet is losing. So that is the concept that we are working. So consider, okay, consider that there is a magnet that I keep at the center. There is a magnet that I keep at the center. Then there is iron that move like this. Iron move in a circular fashion. Okay, now people would say that iron is moving because of gravitational pull also. Consider like this. Many times I have said, this is x-axis, this is y-axis, this is z-axis. If that is the case, consider this is lying on xy plane. Now I am rotating it, y-axis, I am rotating it like this. I just rotated it, but the phenomena is happening on the xy plane only. To show it clearly, I am showing it like this. So this is x-axis, this is y-axis. But actually, things are happening on the xy plane only. Okay, if that is the scenario, then the magnet iron is moving, iron is kept here. Iron is kept here, and magnet is kept here. Okay, iron is moving like this somehow. Iron is moving like this, then how much is the energy, how much energy magnet is losing because iron is moving in a circular direction? That is the question. Magnet is kept at the center and iron is moving along the circular direction. Anyone would say iron would directly go towards the magnet rather than moving in a circular direction. Consider there is a bolt that has a hole, and bolt is inserted in this kind of circle circumference. Now bolt can move along the circle one. Now, and there is no friction. Imaginary, there is no friction. Now, when magnet is kept here, bolt is moving like this. Then how much energy magnet is losing when bolt is moving like this? I would say bolt is moving because of magnetic field only, and bolt moved from here to here in horizontal fashion. Bolt moved from here to here because magnet is kept at the center. That is the question. What is the work done by the magnet? How much magnet is losing energy is magnetic force. Magnetic force into displacement. Work done is force vector dot displacement vector. Okay, in integral calculus we have seen that magnetic force is, if magnetic force is algebraic, then better to go with the integral calculus rather than doing the force vector dot displacement vector. Okay, so through integral calculus, we have, please watch our previous video. So through integral calculus, we have seen that work done is force vector dot d of position vector. What is position vector? If I take, consider this is centered at the origin, centered at the origin. If I take any point x comma y here from center, if I draw a vector, that vector is xi plus yj, then energy that magnet is losing, or energy that magnet, the work magnet is doing is force vector. Consider the force vector is capital F. Write capital F, on top of it write one arrow, capital F. Capital F is the vector field. Capital F is the magnetic vector, magnetic force. Capital F dot D of position vector. Position vector is xi plus yj. Now, consider the magnetic force capital F is dissembled into F1I plus F2j. It is F1I plus F2j d of xi plus yj. That is the position vector. I am not talking about displacement. This is displacement vector. At this point, displacement vector is that is tangential. At this point, position vector is, that is radial. Position vector and displacement vector are 90 degrees to each other as far as circle is concerned. If it was a straight line and it was a center here, then this is the position vector. This is a straight line. This is the position vector. Okay. Now, but displacement vector is along the line. Not necessarily that each point position. This is position vector. It is changing like this. From origin, position vector is changing like this along the line. Whereas displacement vector is along the line, that is a constant vector. At every point, they have separate angle from the position vector and displacement vector. But as far as circle is concerned, the position vector and displacement vector everywhere they are perpendicular to each other. If that is the scenario, then net work done is the force vector capital F is F1I plus F2J and position vector is xi plus yj. F vector dot d of position vector is the work done. F1I plus F2J d of xi plus yj. F1 dx plus F2 dy. That is the work done. Now, this much we understood. From where to where? From this point is considered this point is A or A comma B. And from this point to this point, what is this point? This comma point is alpha comma beta. Okay, this is origin, then this looks like x is 0, whatever it is. And here, if I go along x-axis, this is y is 0. But whatever. Point A comma B to alpha comma beta. So integration from A comma B to alpha comma beta, and then F1 dx plus F2 dy. That is the work done, energy, the kind of this Mr. Magnet is losing. What is the magnetic field? What is the magnetic field that is F1 and F2? Okay, that is matter of question right now. Okay, anyway, now if we kind of consider that energy that magnet is imparting, what is the magnetic field? Consider this is xi plus yj. Repeatedly, I am taking this example. Xi plus yj. Xi plus yj means at the center magnetic field is 0. But if you grow, magnetic field will increase. But actually, it is reverse way. But why I am taking this example is xi plus ya is a radius. Xi plus yj vector is radius. If it is along x-axis, then it is xi, y is 0. If along y-axis, then it is yj, x is 0. Otherwise, it is radial. So, it makes sense. If it is radial, then it makes sense. Okay. Or, no, I do not agree with you. It is radial, it makes sense. Tell me the exact one. Exact one is that I believe the Earth's gravitational pull is minus gm r vector divided by r magnitude of r to the power 3. That is the magnetic field of the Earth. I consider same here, where the magnetic field of magnet that is kept at the center is minus gm. M is the mass of the iron that is moving like this. Minus gm r vector. R vector is this vector. Everywhere this is r vector in polar coordinate system. R vector divided by r magnitude to the power 3. Okay. Now g is the acceleration of the earth. Consider that is acceleration of the magnet. Mass is the mass. So that is constant. M is constant. Minus means it is towards the magnet. So minus gm I can keep outside. R vector. R vector means this is the radial vector. R vector is xi plus yj plus zk. Here z is not there. Xi plus yj divided by magnitude of the radius. So radius, since it is moving around the radius, r is constant. I can keep r to the power 3 outside only. Minus gm by r to the power 3 outside. Integration of r, that is xi plus yj. Same thing came, right? Xi plus yj. Only thing is divided by r to the power 3. That is big. If you keep growing the distance, then magnetic field will decrease. Same thing. So minus gm by r to the power 3, that is full constant along the circumference of the circle. Then integration from point 1 to point B. R is xi plus yj, d of xi plus yj, that is anyway position vector. So xi plus yj, d of xi plus yj, x dx plus y dy. That is the net energy that magnet is losing. What is y? Y, if I see the circle, then x square plus y square equal to a square. Y equal to square root of a square minus x square. If that is the case, then y dy becomes square root of a square minus x square, d of square root of a square minus x square by dx into dx. Dy is dy by dx into dx. That becomes minus x by square root of a square minus x square. Square root of a square minus x square, square root of a square minus x square, gone. It becomes minus x dx. Here x dx minus x dx, 0. No work done. If that is the case, someone can try. Keep a very powerful magnet at the center of a circle and make a bolt, and bolt insert into a circular fashion here, and see bolt is moving or not. Bolt will not move because energy that magnet is losing when bolt has to move in a circular direction is 0. No work done. Okay, this is one thing that we have seen. Other thing we have seen is, consider it is losing energy. Consider the magnet is not kept at the center. Magnet is kept somewhere here. Magnet is kept somewhere here, not at the center. Okay, magnet is kept somewhere here. In that sense, there, if this is the circle, if circle is bigger around the magnet, then again there won't be work done. But here, certainly there will be work done. Okay, in that sense, you have to find the equation of force and displacement. There will be work done. Now, question is arising that if I have a magnet, okay, I'll bring that again. Okay, so this is, consider this is earth or magnet, whatever comes to your mind. So if this is a magnet and this is an iron, and iron is moving toward magnet, then magnet is losing energy. This is what we are saying. If it is moving from point A comma B to alpha comma beta, or point A to alpha, then it lost the energy. Path independence means if this iron is moving in a straight line, or if this iron is moving in a circular fashion, if this iron is moving in a zigzag fashion, whatever it is, it will move in different fashion, right? If iron is a bolt and I place a circular path for this, bolt will move like this towards the magnet. Okay, how much magnet is losing energy? Okay, if it is path independent, then energy lost by the magnet is not dependent upon the path, only from the begin point and end point. This is what we have seen. How we said that this magnet is a path independent, because magnet has magnetic force as capital F. So if magnet has magnetic force is capital F, the net energy that is released from magnet is capital F dot D position vector. That is the energy work done. Capital F, F1I plus F2J d of xi plus yj. F1 dx plus F2 dy is the net work done. If F1 dx plus F2 dy is the g is an algebraic function that resolves into another g, small g. And if dg by dx is F1, and dg by g is F1 dx plus F2 dy, that is guaranteed, which is mixture of vector field and position vector of the path, both. That mixture becomes F1 dx plus F2 dy, where F1 and F2 relationship is capital F, that is the magnetic field or vector field, equal to F1I plus F2J. Now, if F1 dx plus F2 dy becomes g, that is the normal integration. Limit is from a to alpha, or a comma b to alpha comma beta. If dg by dx is F1 and dg by dy is F2, dg by dx, that is the resultant algebraic function. If dg by dx is F1 and dg by dx dy is F2, then we saw this is a case of path independence, because the net result is only dependent upon F1 and F2. dg by dx is F1, dg by dy is F2. It is true that F1 dx plus F2 dy, that is a mixture of displacement vector and position vector of the path and force vector, but result is coming at g, and dg by dx is F1, dg by dy is F2, means result is only depend upon F1 and F2. Then we say, and then at the end the final result is from lower limit to higher limit on the g. So we say that this is path independent. Path independent, whatever energy the magnet is losing from the begin point to end point only, and the magnetic force field, not on the path it is taking. So this is called path independent. Many proof we have given for the path independent. Let's go for one more proof. Okay, so one proof we gave that item is going from here to here. and one path is here to here, and one path is here to here. From this path, we calculated the net energy losing. In this path, we calculated the net energy losing. From this path, we went with dg by dx, and this path we went by dg by dy. And from this path, we saw it results in F1, and this path it resolves in F2 at point x0, y0. That is the first proof we. Second proof we gave that at any point, if there is a 3D, there is a 3D shape. This is 3D shape. When this is 3D shape, it is centered at the origin. If I take any point here, x comma y comma z, any point. So x and y, this is xy plane on top of which 3D item is kept. X axis independent, y axis independent, z axis dependent upon xy axis or xy plane. Z axis is dependent upon xy plane. If z axis is dependent upon xy plane, z axis is dependent upon xy plane, then z is very. So if I take any point here, what we saw, if I take any point here, then the z at this moment, the z, that is the height, is dz by dx into x, where dz by dy is the tangent at this point, dz by dy into y. If I add z equal to dz by dx, consider this point is x0, y0. Then at this point, the z, the height is dz by dx, change in z with respect to x at x equal to x0 into x plus dz by dy, change in y, change in z with respect to y at y equal to y0 into y. What is say z equal to dz by dx at x equal to x0 into x plus dz by dy at y equal to y0 into y. What is z? Z is function over x and y. Z is the height. That is the equation of the tangent surface. If dz by dx is the tangent line in xz plane, dz by dy is the tangent line in yz plane, then dz by dx into x plus dz by dy into y at point x0, y0 is a tangential surface equation at point x0, y0. This is xy plane. If I say this is x0, y0 and fx0, y0, three point in the Cartesian coordinate system. If I see from top and then it go and map on the xy plane, that point is x0, y0. Okay, so this is the, what is the equation of tangent surface at any point? What is your point? My point is alpha comma beta comma function over alpha comma beta, that is z. Okay, what is the tangent at this point? Equation of the tangent at this point. Then that is the equation of tangential surface at that point, that is z, equal at that point alpha comma beta is dz by dx calculated at x equal to alpha into x plus dz by dy calculated at y equal to beta into y. So now if that is the case, that is the equation of surface. Understood. Now at this point alpha comma beta, at this point, if I make small displacement along x-axis, delta x displacement, at that alpha comma beta, alpha plus delta x, and if I make delta y displacement along y-axis, that is beta comma delta y, alpha plus delta x, beta plus delta y. At that point, what is new z? At alpha comma beta, z is z. if z is z. At alpha plus delta x and beta plus delta y, what is new z? Oh, okay, I got it. What is it? What is change in the z that you saw? That is called delta z. If you go with delta z, then delta z equal to dz by dx into delta x plus dz by dy into delta y. It is simple, right? Dz by dx, that is the changing nature when of the z with respect to x multiplied by delta x, that much the z would change when there is a delta x change at point x equal to alpha. Dz by dy is the changing nature of z with respect to y at, and if you make delta y change at point y equal to beta, that much y is changing. If you add these two changes, that is the net change in z. Delta z equal to dz by dx, delta x plus dz by dy delta y. If dz by dx resolves in an algebraic equation, dz by dy resolves in an algebraic equation, then you can say that plainly in a kind of a generic fashion that dz equal to dz by dx, whatever it comes, del dx, delta x becomes dx plus dz by dy dy. Okay, now dz by dx, dz by, consider this z is g. We are calculating net energy, right? That is f1 dx plus f2 dy. That integration resolves into g, that it resolves into g. Now f1 that is f1 dx plus f2 dy. If f1 is dg by dx, consider for luck, f1 is dg by dx. It is not possible in every equation. First consider f1 is dg by dx, then dg by dx plus dg by dy into dy is the net work done. If that is the case, then dg by dx into dx plus dg by dy into dy is dg. Like the dz, what we calculated right now, dz equal to dz by dx into dx plus dz by dy into dy. Here dg by dx into dx plus dg by dy into dy. It will resolve in d of g algebraic function. D of g integration is g. Now lower limit to higher limit. So if g that is the net work energy is equal to df1 by dx, sorry, dg by dx is f1 and dgxy, actually it is gxy. dg by dx is f1 and dg by dy is f2. Then I am sure that this is path independent because it will resolve into dg. Integration is g and lower limit to higher limit. This is the second proof we gave. People, this was our proof, very solid proof. Now people in the world, they are not silent. People keep thinking. After all, it's a human mind, and they keep thinking. Okay, now people thought in other fashion. If this is the, consider this is the, there is one magnet here, there is one magnet here, magnetic field is all around. One item is moving from a point called A to point called alpha, from A to alpha, or from A comma B in xy plane to alpha comma beta. One item is moving like this. Item is moving like this. Okay, as per the integration, the energy is from A to alpha. As per the integration, A to alpha is nothing but A to what I can say, A to X, A to M, M to alpha. Integration is same, right? If integration is from alpha to beta, it is same as alpha to M and M to beta. You just add it. So if I am calculating energy that this this magnet is losing, because one item would not move away from the magnet. Okay, but consider it is moving away. Magnet is on this side. Then item is moving from here to here. Whatever it is. Item is moving from here to here. This point is A comma B and this point is alpha comma beta. Now from, I can say it is first going vertically and then going horizontally. From A to M, this point is M comma N. From this point is A comma B. From A to M, M to alpha, the item is going. The energy that this item is losing is from A to M and then M to alpha. From A to M, the energy it is losing is F1 dx plus F2 dy A to M. From here to here, it is losing energy, that is F1 dx plus F2 dy M to alpha. A to alpha got divided into two parts. Okay, now leave it. Now leave it. Okay, the idea is we are talking about path independence. Hope. Now, these are the two paths we are talking, right? This point is A comma B. Explanation is ours, but the main idea is not ours. So this point is A comma B, and this point is alpha comma beta. This point is M comma N. Actually, the item is moving from here to here. How much energy this magnet is losing? If it is losing from here to here, if it is losing from here to here, it is going A to M. Then from M, it is going M to alpha. From here to here. Now, what are the force field? Force field capital F equal to F1I plus F2J. Capital F equal to F1I plus F2J. Now, what is F1? What is F1I? F1I is the force component along x-axis. That is F1. So this is x-axis, this is y-axis. F1 is along x-axis, F2 is along y-axis. That is the force field. F1 can be a function over x and y. That is the vector field. Vector field where F1 is function over x and y. That is F1. And F2 is again function over x and y. But F2 is going in y direction and F1 is going in x direction. Okay. Now consider F1 is x and F2 is y. Then how much? This is F1. This is F1. This is x-axis and this is F1. If I move along y-axis, then F1 is changed. F1 is x. No, because it does not have any y component at all. Makes sense? The force field of magnet, capital F vector equal to F1I plus F2J. F1I vector plus F2J vector as per the vector representation of addition of the orthogonal component. In that fashion, if it is addition of orthogonal component, then in that fashion F1 is algebraic function. F2 is algebraic function. F1 is algebraic function and F2 is algebraic function. In that sense, F1 is x and F2 is y. Xi plus yj is the force field. Now this is the force vector in along the x-axis, that is x. X is this force vector. If I take along y-axis, this force vector is changing or not? Not changing. Everywhere it is xi only. Similarly, the F2 component is yj. If I take along x-axis, y is changing or not? It is not changing. Okay, if this is not changing, consider that there is a line and this is the force vector. Here force vector is xi and here force vector is xi. So if I keep this force vector, then this will try to push this line in this direction. Make sense? Okay, what I'm trying to say, it is not changing. Now similarly, line is in this direction and F2 is in this direction. If I see F2, then it is not changing along the x-axis. It will push this in this direction. What is the idea here? F1 is, if the line, this is the line, right? From A to M. And this is the line M to alpha. If this line is there, F1 component, if F1 component is there, it will push in this direction. Because like that, F2 will push in this direction. So if this is this is this. This will go in some direction. But what is the concept here? Concept is this is not feeling any torque here. What do you mean by torque? What is torque? What is torque? Okay, what is torque? Torque means if F1, this is the F1. If F1 will change as we go along y-axis, then here F1 is different and here F1 is different. Consider this F1 is dF1 by dy. This is what I am talking. dF1 by dy. See the people how much they think. This is the F1 is the force field I component, x component. If this F1 at this is x-axis, if F1 at x-axis is different and F1 at x along the x-axis only, but when y is 0 and y is something, at that point F1 is changing. Means dF1 by dy is there. Consider F1 equal to y into cos x. F1 is y. Force field is y cos xi plus y sin xj. Y cos xi plus y sin xj is the force field. The x component is y cos x. dF1 by dy is cos x. Means F1 is changing as we go along y direction. If that is the case, then if there is a line and this is the force, here force is more and here force is less, then it will rotate, it will make a torque like this. Hop, 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 hop. Make sense? It will make a torque like this. Okay, that is one thing. Now consider that this is another line, that is M2 alpha, and there is F2. If there is F2 dF2 by dx is there, as we move along x axis, then force will are different. Okay, if I go along and then it is force is decreasing along this, dF2 by dx is negative, means force is decreasing. In that sense, there will be torque like this. So if I have a path from A to alpha, and this is the path where it is A comma B, this is M comma N, this is alpha comma beta. If this is the path that I broke into two parts, one part is completely perpendicular, one part is along the I-axis. Force is along the I-axis, the line is completely perpendicular. One is perpendicular, so this is perpendicular to F1. This is perpendicular to F2. So F1, if there is a dF1 by dy is there, then this path will see a torque. If it is seeing torque like this, then this side F1 is more. dF1 by dx is positive. If this is getting torque like this because of this line, then dF2 by dx is positive. dF1 by dy is positive, then it will get torque like this. If dF2 by dx is positive, then it will get torque like this. Then they are nullifying each other. If dF1 by dy equal to dF2 by dx, then they are nullifying each other. I took very coarse way. If I take any path from this point to this point, and dF1 by dy is same as dF2 by dx, at every moment the change what we see in F1 as we go along y-axis, and change I see in F2 when we go along x-axis, then they are nullifying each other. If they are nullifying each other, this means that path has no meaning. Along the full path, they are nullifying each other. If means change, their change are nullifying each other, then there won't be any torque. If there is no torque, then they are nullifying each other. In that case, it is balanced. If it is balanced, then path has no meaning. If path has no meaning, then what is the net energy calculation? That is F1 dx plus F2 dy is completely path independent, that is dependent upon begin point and end point only, because dF1 by dy is same as dF2 by dx. In that fashion, if dF1 by dy, because of that this path is getting a torque, then this is nullifying by dF2 by dy. If they nullify each other, then it is completely positive, because along the path their gradient are nullifying each other. Then it is completely positive. Take any path, they will keep nullifying each other, because any if you take any small section of the path, then you can dissociate between, you can take two parts. If there is a path like this, there is a path like this curve, take any small part in the path and make like this, then they will nullify each other. So they will nullify each other at every moment. It is not dependent upon the path only. Okay, we'll move on this. So here we are entering into commercial calculus, and there is a Green's theorem based upon it. So I believe it is too much. So we will talk more on it. If dF1 by dx and dF2 by dy, then again it is path independent. If dF1 by dy is same as dF2 by dx, then again it is path independent. Then what about g? At the end we calculated g, right? It is also called potential function. dg by dx, dg by dy, if equal to F1 and not required. This is another way. Okay, so that we will talk. Explanation is ours, but the actual proof is not actual. The idea is not ours. Anyway, please do support us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code. We will see. Interesting, right?